Good afternoon. You all here for Math 210, brief calculus? I'm in the right place. She went up to 210 upstairs, and I realized I was looking at the course number instead of the room number. So yeah, if you're engineering, I think you're up there. Okay. I was almost there, but fortunately there's another.
So we got to go upstairs, you said?
Yeah, just your professor setting up there. All right, so the rest of you, hopefully you're here for brief calculus. How many of you are business majors? Not uncommon, but I bet you there's a few, maybe biology? No. Any other than business majors? Computer science, I think, can also take this class. Okay, so we're mostly business. Catch my breath, it's a long one. It took me 20 minutes from my office here, so I was testing it out. I also got an email from one of your fellow students. I don't know if you made it or not, but he was saying that he's got a class right before this and it might take more than 15 minutes to get here. Get here when you can. So I didn't even know we had classrooms out this far. So, next time I'll call it Uber or something, right? Okay, so I picked this up as a second section. I also teach the same class Tuesday, Thursday morning at 7:30. So I went with one Canvas course that incorporates both of them. And actually we're going to use one web assigned course, which is the homework, where y'all will be in there doing your homework. So I basically just make one update, everybody's got it. Today we'll go over sort of how the course is going to work, how we're going to build success, and how we build in flexibility so that we can all succeed. That's our goal. Is we have exactly 89 students registered for this course, and the fire code says 89 students could be in here, so I guess I'm in violation because I'm the 90th, but I don't know if that maybe is students and they allow for one extra, but we are at capacity. And I was asked to add a few more, and I can't, because that's fire code. So anyway, we are full, and I'd like to see 89 across the finish line successfully as well. So we'll go over the course itself. We'll start into the first one or two sections of the course that I have lined out. We'll see, we might push the second one until Thursday, depending on how much time we spend on the course policies and such. But what I'd like to start off with first of all, also I record, I'm doing a screencast, so it records what's on my screen and records my voice. Usually I have a little Bluetooth thing so I can wander around, but I forgot it at home, so that's why I'm kind of trying to stay close to the computer so it records my voice. What I do that for two reasons. If you miss class, you'll still be able to hear and see everything that went on in class that day. If you were here, oftentimes you may find it beneficial to go back and review something that maybe you missed in your notes, or maybe this allows you to focus on just kind of learning things and then later go back and take notes, or vice versa, however it works. But I do record every session. And so actually that means there's going to be two sessions recorded because I did the same show on last Thursday. So that's already recorded, but you'll see what happened in this particular section as well. And sometimes they're a little bit different. But you'll see I've got things organized by content, by section in the textbook. So since most of you, or maybe all of you, are business majors, what I like to bring out, what calculus is about, and what we're learning is rates of change. That's all it is. So if you've done algebra before, which hopefully you have because that's a prerequisite for this course, you know the slope of a line, that's rate of change, how things are changing. Where am I going to be tomorrow? That's a rate of change. Where I am today, algebra usually answers the question of where I solve an equation in the algebra and I find out where I am. Calculus tells us if things continue as they are, where will I be tomorrow? Will my profits be going up or will they be going down? Should I spend more money? Should I invest more? Or should I pull back? Should I hire more employees? Those are the kinds of decisions it's going to help us make. Simply by looking at the rate of change, which we also call the derivative, so we get multiple names for this. We do start off with an algebraic look at things, because that's really all it is the slope. So if you can calculate the slope, remember the formula y2 minus y1 over x2 minus x1, something like that. That's what we're going to be doing, but we use some techniques that allow us to get that rate of change for a lot of different types of functions, not just a linear function. So I like to start off with a little story. I've been teaching for 24 years. Started at Oregon State University 1998. Came to Arizona in 2004, taught at Scottsdale Community College for 14 years. And then I came over here in 2018. Primarily because I wanted to also get a doctorate degree, and I get a waiver if I teach here, and I did get that waiver when I was at Scottsdale. So I finished my program in spring, so now I could just focus on teaching. And my doctorate was not in math, it was in educational innovations. So I'm an educator first, and math is just the content I teach. I'm not a mathematician, I tried that once, but I am a math educator, so that's my goal, to help you learn. Before that, for 13 years, I was in financial planning. I worked in an agency that did insurance, life insurance, health insurance. That's pretty much it. Disability insurance, and mutual funds. And they expanded into stocks and bonds as well. I was studying for the Series 7. Anyone in finance who knows what that is? It's a test you take so you can sell mutual funds. But that's when I decided to switch over to education. But during those 13 years, we had a client, my boss had a client, I did all the workups and all the presentations and such. But one of our clients, this was in Oregon, I'm from Corvallis, Oregon. He lived down in Eugene. And anyone know anything about Oregon? What do we have a lot of in Oregon? What is Oregon famous for?
Right.
Rain, you got it. And rain produces a lot of green stuff, trees. So we also have a lot of rain, a lot of trees. So our client, Mr. Vickers, ran a plywood company. So part of the process is he wasn't a lumber mill where they cut the wood, but he would buy the veneer, the little sheets, glue them together, that made plywood, and he'd sell them. What he found when he was working through that, he grew up in the business, it was a family business, was that he got real good at looking at the prices of veneer, which is the raw materials that you make into plywood. And he cut so he could anticipate. He could see the derivative in the data he looked at. He never had calculus, but he was using calculus techniques. He could predict whether the price was going to go up or down tomorrow. So he would buy his veneer, and by his analysis, by his intuitive calculus, he was able to determine whether he should turn that veneer into plywood and sell it as plywood, make his profit that way, or whether he should let them deliver it, let it sit, and then he could sell it to somebody else for a profit without ever putting any effort into it. And he went from being about $1 million business to about a $10 million business. This was back in the 1990s, in a short period of time. So he took this business that had been around for a long time, said it was, it was $1 million business, but he built it into over $10 million. The problem was he didn't know exactly how to teach what he was doing, because he didn't know calculus techniques. He just knew he looked at the numbers and he could see where things were going. But that's what I hope you gain from this course. The ability to look at the numbers in your field. If you're in marketing, it's going to be, how many sales are we doing and stuff, and where should we be marketing? It's growing here, this segment, the 15 to 20-year-olds, they're really buying this stuff up. We need to go with that segment. Or should we go with the older segment? So you're going to be able to do that, but that's by looking at the numbers. So we look at calculus, the mathematics we're going to look at is a real conceptual look. We will get techniques, but I don't want you to just get caught up in the equations themselves, but I want you to understand the concepts that we're dealing with, is that it's a rate of change. That what we're doing is we're seeing how, not necessarily the numbers themselves where they take us, but where the rates are taking us, how fast it's changing on us, and where we're going to go next. Okay, so that's the goal. And again, you'll do that with finance. If you're in investments, how do you recommend your clients, which ones, we want to, it's not so much when we buy today, but we want to see where's it going, right? Same thing when you're doing business management. You're going to have to make decisions on a daily basis and you've got to know, is this the right decision? And that's only going to be determined by the future, whether we got better results or not. Okay. So, and with that in mind, I will do my best to bring in, let me just download this. I will do my best to bring in examples, content from business applications. The textbook is designed that way anyway, but we'll do our best to even make it more meaningful. I think one person has already contacted me about an honors contract, so if you're doing honors, we can do it with this course. Typically with 100 level math courses, they don't let us do it, but I've mentored several interesting projects, and again, all you have to do is think about whatever field you're in, what is the rate of change? What is that derivative? And we can do a little bit of research and do a conceptual paper that will help you. I had one in spring who was on finance, and he was looking at Bitcoin a lot, and so he did a paper on the rate of change, the effect of Bitcoin, those kind of things. So see that I don't think I need to update this. What I'm going to do with my office hours is I was also going to take an evening class tonight and Wednesday, and that was part of the reason why I picked up this class, because I'll just teach a class and then I'll go to class. But I decided I'm tired of school, I'm tired of being a student, at least so I'm going to give myself another break. I dropped my classes, I'm just going to teach. So instead of having, see where's office hours, instead of doing the Monday after class, I'll consistently do it the hour before class. Okay, so you can, and again, like when we have exams, I can extend that. I don't have any other classes this day, so I can start a little bit earlier, and we could have like review sessions before exams and stuff. So we'll work on that, but just let me know what you need. We can meet before class. I don't have anything directly after this class now, so if you have questions, we can also maybe just go in the courtyard here after class and get those answered as well. Okay, so that's the first thing. Is a lot of times with math, there's one little thing that's holding you back, and if we talk it out, we can figure out what that is, and you get moving forward. But if you don't get it talked out, it's for you. It's not a little thing. It's something that you can't move forward on, stopping you completely. So my contact information. What's that? Oh, I'm wondering. So there's my contact information, anything you need. To get enrolled in the WebAssign course, there is this link. You can just click on it, and it will take you, and it will copy over the access code and everything, get you to the place. You can also go to the webassign.net and manually type in this ASU 6901-1467. How many of you have already gotten the access to the WebAssign? Okay, good. A few of you, it's okay. Hopefully in the next couple days, by Wednesday, you're all into it and going. I believe I've got 3 different systems that I'm using, and I believe WebAssign, once you register, you get temporary access for 2 weeks before you have to pay it. And I'll look it up, maybe it's in here somewhere, but I can't remember. Some of them, what they do is they will bill your student account, so you just pay your student account, you're fine. Others, they will bill you separately. I can't remember which one this one is. I think this one gets billed through the student account as well. But anyway, get the access, get started, and we'll be good. All right. So these are our learning outcomes. I'm not going to go through each one of them, and I just know the course will do them. It's a lot easier once we're done. You could probably read this list and say, yeah, we did all that stuff. So, but reading it in advance, to me, has never been, even as a teacher, is not really enlightening. I like to go to the text. So our textbook is not a physical textbook. I mean, you could get one if you wanted one, you could order it, but it's an ebook inside the WebAssign homework system. So you'll need that access. I think it's about $100 that will get charged. You can either through your student account or that you pay for it. Includes the book, everything you need to do the homework and such. A graphing calculator is really required. Again, only because a lot of the things we're going to do, you'll need it. In fact, today's content that we're going to take a look at, you're going to see me using one. I've got one that you can use, you can download onto a smartphone or to a computer. It's called NumWorks. I'm going to demonstrate it a little bit. You can also, the nice thing about that one is you can use it, but obviously you can't, I don't know if it's obvious, but you can't use a cell phone on an exam because it's also got internet access. But NumWorks is one that you can download, use, and then you could also buy a physical calculator that's just a calculator for $99 if you decide to go that route. If you've got a TI 83, 84, that works perfectly too. Casio has a lot of different graphing calculators. The only ones that they say can't be used, it has a CAS, which is a computer algebra system. The department doesn't allow those. I figure if you know how to use that, you're probably smarter than me because they're kind of hard to figure out. But anyway, talk to me if you have any questions about your calculator. But a graphing calculator is going to be almost necessary. Almost, you can't do it without one. Although I've had students who still don't, they didn't grow up using calculators, whatever. And there are methods you can get around, but typically you're going to find having a graphing calculator is going to make things much nicer. Okay, we've got some links in here for learning how to use the graphing calculator and different techniques. We'll also demonstrate those in class. There's some links here so we'll have what we have. We have 3 exams and sort of during the semester, and then 1 final exam. So 4 exams in total. Each exam has a review, which is available on the website. I'll also post those as they're like PDF files. I'll post those inside our Canvas when we get there. You might even be there. I do some solution videos for each of the problems, so you can kind of try them. You can watch those videos. We'll have time in class to work them out, office hours, those kind of things. But do mark these dates for, let's see, I got the Monday class here. So two exams are on Monday, one's on Wednesday, and then we got our final exam is a group final, common final on Thursday, December 7th, which is the last day of finals week. So make sure you make all your plans with that in mind. Now, if you notice I've got a Tuesday class. This meets at 7:30. So if something happens and you can't make this one, yes, I could pick you up on the Tuesday class. They have a little bit more room in there. But try as best as you can to be available those days to take the exams. Our homework's about 10% quizzes. What I use the quizzes for are really exam prep. What I may do is move some of this, maybe 5% over to the homework since you're already doing it. And the quizzes will all be not like an exam or anything. They will really be worksheets that prepare you for the tests. So this 25% of the course really is based upon effort and doing the homework, doing the reviews for the exams. 50% is the 3 exams, and then 25% for the final. So 75% is based on the exam. You cannot pass this class without doing reasonably well on the exams. Okay. Now technically you could get a high D on all the exams and do all the homework and you'll still pass. But what we would like to see is up in the 80s and 90s so that you're really proficient in what you're doing. But yeah, it's possible to actually fail the exams or get Ds and still pass, but we'll hopefully get you so that you're feeling confident and comfortable with the exams before we take them. Got the grading scale here. Here's our blurb about the homework, and The other thing I'll let you know is I did not write this syllabus. It was given to me. So I tried to go through, and sometimes I don't have the same tone, and I know this coordinator has sort of a different philosophy of teaching than I do. So it has a little bit different tone. Some of it I change, some of it I miss. So if it's, you might pick that up as you go through. It might seem like there's a nice part here, and then, wow, it's really being strict over here. So I write the ones that are a little bit more towards the kind side. Strictness is only that if you can stay on track with things, it's going to be best for you as well. If you can't, what happens is then things pile up a little bit. But sometimes, life happens, you have to take care of some things, and it's going to pile up, but you'll adjust and you'll make up for those. And if you do that, we're all fine. So, missing class, yes, you should be in class as much as you possibly can, but when things happen and you need to be somewhere else, my grandfather was on dialysis for 10 years, and we always needed someone to take him to his dialysis. And if the regular person someone fell through, one of us would have to drop what we were doing, take him to his dialysis. If that's you, okay, I'll understand, and that's why I record, so that you can pick it up. No penalties. So I don't take attendance. Be here when you need to be here. Keep track of yourself. Keep track of your learning. That's the thing that we're going to assess. Okay, so here's some links for that. Basically the WebAssign is the name of the software we use by Pearson, I think it is. Yeah, I think it's Pearson. All these different companies. So quizzes, what I use those for, and I don't do them as, you have to be here, and if you're not here, no makeups and all that kind of stuff. But they will be short, test-like questions that you get to test yourself on, work through them. If you don't get them right, that's okay, you tried them, but then you'll study them until you can get them right, because you're going to be facing a similar type question on the exam. Okay, so that's what the quizzes are about. They're activities to prepare you for the exams. And then we'll have the exams, take them during class period, and then the final will be in some other building somewhere, because it's a common final. Okay. And again, I'll let you read through a lot of these. Actually, this is probably a good place. There's attendance. Again, I didn't write all this stuff. Let me stop here and tell you, I got 2 rules that can take care of all of this stuff. 2 rules based on one thing. What is the thing that we own, that we really own, that's ours? This computer mine? I say it's mine, it says my laptop, right? But somebody could take it from me and now it's their laptop. Or it breaks and I say, this ain't my laptop anymore, I'm getting a new one. So what we really own is our actions. Because if we did something, right, we did it, we own that. If we could agree that our actions are the result of our choices, again, sometimes it's, he made me do that, right? No, I made myself do it. Maybe I let somebody influence me to do something, but we own our actions. If we agree with that, then there's the only 2 rules we need is that there's 2 types of actions we can do. There's skillful actions and unskillful. Is that easy? And again, instead of, I grew up, I was baptized Catholic, went to Catholic school, was fundamental Christian for a while, now Buddhist, and a Buddhist is a much freer way of looking at things. So I know what it's like dealing with sin and being wrong and being punished for what you did. But in this way of looking at things, we're either skillful in what we do, and if we're skillful, what's happening? How do we know when we're skillful? They knock on our door and they come say, hey, you're doing great things, right? We're getting success, right? Skillful things lead us to success. When we're doing things right, we learn. We make advancements. When we're unskillful, we might have some fun that night, great party, but then we missed the exam the next day because we overslept. I said, man, that wasn't, you know. The thing is skillful and unskillful are situational sometimes too. Some of you all, when you study, how many of you listen to music? Some of you find that to be a skillful thing. When I do that, I get into the music and I stop studying. So for me, it's like I don't get done what I might have a good time listening to that music, but I don't get done what I intended to do. I watch TV and I think I can watch TV and do some work too. I get into the movie and okay, I'm gone. So some of us, it's a skillful thing. It keeps us focused on something and we're doing something, that's fine. Others, it's unskillful. So this is a thing where we have to determine. Yeah, do I need to be in class? Well, sometimes that's a skillful thing to do, but again, if Grandpa needs dialysis and somebody has to take him, maybe it was actually a better skillful thing to go take Grandpa to dialysis and deal with the class later. Okay? So you've got to be the one that makes those decisions. So those are my 2 rules, and the rule is try to be as skillful as you can in your decisions, in your actions, and when you find yourself not, when you determine that, hey, I wasn't being skillful, I wasn't studying in a way that was helpful or something, then try to move away from that, right, and move towards being more skillful. The other thing with that, and this covers all the rules, is that if by definition, if we do harm to ourselves or others, that's by definition unskillful. Because how many of you want to have a crappy life? You want to be happy, right? Most of us. So happiness comes from not harming ourselves, not harming the other person either. Because if we harm them, they're going to harm us, right? They get you got me, I get you. So if we agree on just those 2 rules, try to do no harm to ourselves or others, try to be as skillful as we can be. When we're unskillful, try to make amends and move towards it. We got all this stuff covered. We don't need rules on, do I have to turn my cell phone off? Do I have to do this? Do I have to do that? We'll know. Okay. That's the other part I bring into my teaching is I'm Turtle Mountain Chippewa from North Dakota. Chippewa Cree, actually my grandfather's people come up from northern Canada. And the thing I'm really proud about my people is we lived on the plains for thousands of years without any law. We did not have a law. Because we knew we had a moral code and we knew what was right and we had people, we would take care of things. If someone did something wrong, we dealt with them, you know? And some people, we just talked to them and got them to do the right thing. Others, okay, you go off by yourself, we'll go this way, and you know, we separated. We did what we needed to do. But that was because we followed these sort of 2 rules of don't harm others, don't harm yourself, and try to be, you know, when you're living out the way those people did, when you make a mistake in the harsh weather, you know, you don't live. So to survive, you have to be skillful. Okay. So now we can skip over a lot of this. You can still read this stuff. Main thing is get into the WebAssign, and then that way, what I do is I check the 2 grade books because I need to be able to get the WebAssign grades over to Canvas and everything else, and so you need to get that done this week. Okay, so if you can get that done, at least get yourself rolled up. And again, it doesn't cost you anything because there's this like 2-week time period where they give you access. Get into it and let's get it going. There are various resources. So there's a university study hub on Inscribe. Actually, we don't use Inscribe. But there is, if you go to the website, ASU website, there's a study hub where there are some resources for 210. And again, they've got all these rules of do's and don'ts. I just say if you follow those, you know, be skillful and don't hurt anybody. Be kind to other people. Be kind to yourself. You'll be fine. So we don't need all these rules. It's tutoring resources, so there's some links here. We do have some on-campus tutoring. There are some tutoring centers in the residence halls. So if you have questions about those, let me know. We'll find it, figure it out what works best for you. I'm available again for office hours the hour before class. Can be come here a little bit earlier, so if you need me, let me know. We can meet in my office or we can meet out here in front. I'm also available after class for a period of time. especially if you get me a cup of coffee or something. No, you don't have to do that. Although there's some nice coffee shops I didn't know existed right up the street here. So, and also I'm available on Zoom. So, you know, whatever you need, let me know. We'll make it work. You know, schedule an appointment with me. We'll get up. If you let's see. Got makeup policies and such. Again, if we can, the best thing is communication. If something happens, let me know as soon as you can. The definition of an emergency is you don't care about anything else except for that emergency. So I understand if, you know, your little brother broke his leg and you got to get him to the hospital, that's what you're thinking about. You're not thinking, oh, just lay there for a minute, let me contact my math teacher while no, you take care of your brother's broken leg, right? So that's the idea of an emergency, but contact me when you can. Keep communications open. If you're going to miss a test, let me know. But you know, try to do your best to do it on, you know, in advance when you can. And again, a lot of this is just general stuff. Yeah, so we're through all that, and we haven't seen a calendar yet. What I've done with that is I have that here inside of Canvas. So I got an anticipated schedule for Tuesday, Thursday. You could take a look at that so you know you can kind of see. You're welcome to come to that. I told them, there's a few asked if they could come to this class, and I said sure. We'll probably, again, we're full, but yet there's still a few seats, and it always happens that it's rare that 100% of it, except usually test days, that's when it's filled up, right, hopefully. But we'll make it work. So you can check the other schedule if you need to come to a Tuesday, Thursday, early morning. You're welcome to do that. It's in a different building, but you can look that up too, and we'll get you there. So this will kind of do our pacing. Now we're scheduled to do 10.1 and 10.3, the two things on the limits. We may just, there's kind of like, there's a lot of stuff going on, right? We're getting used to this course, what's in there. We're going to look at one set of concepts. I'm thinking what I'll do is this is related to this, but I think if we take a look at this, I'm going to preemptively move 10.3 over here, and then we'll do two sections, because we'll just start right into the sections on Wednesday. Okay. The homework's set up inside the WebAssign so that if you finish it, whatever you finish 24 hours before the due date, you get an extra 5% extra credit. So if you finish it all, you get 105% of whatever the points are. I try to move the due date out far enough. I can't remember when I got them all set, but I think it's like, I always give you at least a week to get through it. I have no problem moving them a little bit, and if I move the due date, then that 24 hours also moves with it. So that works. But that's sort of one thing, is it's sort of trying to encourage you to get it done early rather than putting a penalty to get it done late. If you need to, what happens after the due date, I think you either lose access or it doesn't give you any more points. I'll just contact me, I'll extend it so you can still get the points for it. I still want you to work through there because that will help you with when we get to the testing situations and such. But I'm not too worried about due dates, but with that being said, I also don't want you the night before the exam on September 18th say, well, I haven't started yet, can you open up all the homework for me? Because it's not really something we don't necessarily just learn by doing it, right? It's not about just finishing that homework, it's actually learning the content as we go. So do your best to stay on track. I'll work with you as far as due dates. Again, I'm not one who, it is helpful if I have some sort of deadlines, but I'm also one that I don't like to be micromanaged and say, you gotta have this by this. I said, well, I'm just not in the mood to do math right now. Can I do it tomorrow? I'll be in a better mood, because I'm better in the morning. If I have to do my work at night, it's a mess. If I can work early morning, that's when I can do my best work. So I want you to also have that flexibility to say, and maybe I work during the week and I do all this stuff, and I don't mind coming to classes and learning stuff, but I do my homework on the weekend or something, give you the flexibility, again, to be as skillful as you can be with all the things going on in your life. Okay, so we do have, since we have Monday, I think we end up with, we have this holiday. I thought we had another one. Yeah, we've got fall break. So we've got 2 Mondays that we're going to lose out on. And the Tuesday, Thursday class, they actually started last week, so we've already done 10.1, so they've actually got an extra day. They don't have any of this, although when we get to Thanksgiving, they lose Thanksgiving, so it's not too, but there's more days that we've lost, or that we don't have that the other section does, so that's why we have we're a little bit, we have less room. They have an extra day in there somewhere. That's okay. Any questions so far? Okay. Good. What do I do next? See, I've been off all summer. I haven't been teaching. I forgot how to do this job. No. Okay. A little humor. Let's do this. So let's go ahead. 4:15. Yeah. So the way I've got this set up is I've got it broken down by exam. So this was based on my class I taught it last spring, was the last time I taught this, so not too far. And before that, I think it was almost a year before that I taught it. So I took a sort of break, and they've done some revisions. And what I'll show you is, so there's a pacing calendar. Oh, but let's see, what do I have in here? Oh, I do. I have them both. So for Tuesday, Thursday, all this is the top part of it's just all the way up to exam 1, so you can kind of focus if you want to. So it's a little bit less, but it's the same schedule. Let me go back. So let me show you what I've got for you in each of the in this section. So we're going to do 10.1 today. 10.3 we're just going to move till Thursday, and I'll make sure due dates are moved and everything. So what you'll get when you come to a section that we're covering is you'll get my video from, and some of these are from, I might have some from spring. This is actually further. This was from fall 2020 when we went on COVID lockdown and it was all virtual. So those I did from home, and I made a little studio, so those are a little bit more produced. The rest of them will be just like this is a class, I'm just doing class. So we'll get a little bit of both. So there's a slide deck, and we're going to pull that up, and that's how I do the lectures. I've got some examples, we'll work through them. So that's the slide deck. It's kind of blanket, but it has the examples that we're going to work. I will have Thursday's lectures posted or Tuesday, so whatever section gets covered. So that's the other class. So you're also, because you come, today you could have actually already looked at that before class. You could have looked at this before class if you're of that mind, and then now you can come. You have 2 choices. You can say, well, that made a lot of sense. I don't even have to come to class because I understand. And maybe you get into homework and say, yeah, I understand this. I'm fine. I'm going to give myself a break. But you know the content, right? Or you may look at it and you say, man, I got lots of questions. I better be in class. And again, so either way. Or maybe you just say, I'm just going to show up in class and see what it's about. And if I need it, I'll go back to these. So multiple ways to use it. And then there's this will become a link after, well, I might get it done this evening, or it might be early tomorrow morning. But I will download this I use a YouTube page. That's where I have everything posted. You'll actually, once you go to that link, you could look at my previous stuff. I've got exam review questions and such, so there's a lot of resources I have there as well. So you can go there. But that's basically what you'll see is the outline for each section. If you go to 10.3, you'll see sort of the same thing. Again, until we've covered it, you won't see these links won't be active, but there will always be a previous lecture. So again, if you know something's coming up and you're not going to be in class, it might be, if you can preemptively look at things, then you know whether or not you still have questions. And again, it's great if you can go through the lecture and say, okay, this makes all sense. Let me try a few of the homework. I can do this stuff. I'm going to be okay. Then you've answered the question. Yeah, it's okay for you to miss class because you're going to be just fine with the content. Right? Where does the learning occur? It really doesn't occur in this classroom. It occurs up here, right? And I've had great students. In fact, actually, one of my best students when I was doing my student teaching in high school, because that's where I started as a high school teacher. And I felt real proud of myself because one of my students it was in Salem, Oregon, she got the highest score on the district final exam. So, wow, I did a real good job. And I found out who it was. That was a girl who had been sick all semester and hadn't made a day of class. She taught herself. It wasn't what I did, right? So that's the thing, is it's about what you learn and how you learn it. And you can do that on your own, so I'll give you those resources, but I'm also here to work with you and make it all happen. But the bottom line is, I hope all of you get the highest score on the test. Yeah, you can all get 100%. And I can't. Even on my own test, I usually only get about 95. So, but hey, I'm dyslexic, so it's like sometimes you might think I'm making mistakes on purpose, but if they're not on purpose, they just happen. Okay, I twist numbers, but it just works. Okay, so we're going to click on here. Takes us to my Google Drive, is where all these things are stored. I'm going to go ahead and let me get my tools showing here so I can do a little writing when I need to. And we're going to go into this first section, maybe 15-20 minutes. We'll end 15-20 minutes, or 10 to 15 minutes early in case you have any questions or want to talk or anything. But this will just kind of get us into a pace of where we're going, what we're doing. And we're going to start off with this concept of something called a limit. How many of you are in finance? How many are in supply chain? That used to be. All right. In my other class, I didn't have anyone in supply chain. We were used to that. Used to that should be okay. How about business management? You? Marketing. Good. All right. General business and maybe. Okay. Good. So, what is a limit? It's a weird word, even for mathematics purposes. I was always wondering what it was. The thing is we've actually got a lot of experience with what a limit is, but we just need to define it. So the basic idea is that the limit, it's all this technical stuff that we do, is that, we'll start down here, that a limit comes from a function, a mathematical function. Mathematical function has two things. You put in a number, you do some math on it, and out comes a number. So we've got an input number and an output number. That's all there is. The input number is what we call, comes from the domain. Again, it's just a name we use for the numbers that we're going to use as inputs. Typically, that's our x value, the x part of the function. On the graph, that's the horizontal axis, right? So that's our input. The output is the y value, the number that comes out of that function. We call that the range, again, just a name for it. And basically what the limit is the y value. We've got a function, we put in an x value, we get its answer, out comes the y value. That's what we're talking about, the limit. So that's what I mean, you have experience with this. If you've ever done any kind of algebra, you plug in a value for x, you get a value for y, that's what we're calling the limit. The thing is what we're using this concept of limit, where we really need it, is when we put in a value and we actually can't get an output value that makes any sense. So it's either undefined there. So then what we're doing, the concept of a limit, since the y value itself doesn't actually exist, the idea what the limit is, well, what would that y value be if it did exist? Or can we make it so it will be close? So what we do is we look from the left and the right, and sometimes what's happened to that function is it's just got a hole at that one point. So it doesn't exist at that particular value, but everything else around it works, and so we can just say, hey, let's put a little bit of filler, fill in the pothole, and let's just say that the limit is 2. So even though it doesn't actually exist. So that's what we're using limits for, is for the instance when we don't actually get a output value. But we're going to also look at them where we've done with algebra, we just put in a value, get this, and that's what the limit is. And then we're also going to look numerically for when it doesn't exist, what would it be? Is there a number that is really close to it? And sometimes it doesn't exist at all. And we're going to see that's because from the left it's down here, from the right it's like there's this big space in between. And that's all we're going to deal with limits today. Okay, so what we're doing is we're going to numerically use a graphing calculator to get the x value as close as we want to the value, say x equals 3. So we're going to look at x equals 2.9, 2.99, 2.999, 2.999. So we're getting as close to 3. And we're going to come from the other way, so we'll look at 3.1, 3.01, 3.001, so we're getting close from both sides. And if we get to a value where that output value is close to something, even though the value at 3 might not exist, that's what the limit is. That's all it is. Okay, so again, we're going to start with functions where the limit, the y value actually exists, and so we just plug in the x value, we get the y value, and it's very simple. But then we're also going to get some techniques that allow us to find limits when it's a little bit harder. So let me take on this one. So here's our function, 2 plus x. The notation is saying that that's what it's asking for is the limit, it's LIM, and it's as x goes towards 3. So that little arrow is just, we would read that as goes towards. And again, we've got to think of this, it's going towards 3, both from the left and the right. So we can also, we won't use it as much, but we can also think of a left-hand limit that would be going towards 3 from the negative side or from the left side, and we denote it this way. Or we can also look at the limit as x goes to 3 from the positive side, or from the right-hand side. So that's that notation. So there's actually two. We look at those two limits, and if they're the same, then we say, oh, the whole limit as x goes to 3 goes to the same thing. So first of all, let's take a look at this as 2 plus x. If we plug in 3 for x, what do we get?
5.
2 plus 3 is 5. It worked, didn't it? We're going to look at mathematically, it's all defined that this is okay. This is what's called a closed function, a closed form. And if we have a closed form, yes, you could just plug it in and you get your answer. So we're going to see the limit is 5. That's all it is. I've tried to take the mystery out of this because usually when we teach it, we go into all the definitions and stuff, and I never understood what a limit is until I started teaching them. I'll be honest, I just never knew. I mean, I could get good enough that I could get the right answers and pass the test, but I never really knew what a limit was until I had to think of how to explain it. So this is the limit. But let me now take a look at the same thing from the perspective of what it really means to be a limit, because it isn't really the limit. It's a function value. If we put in 3 and 2 plus 3 is 5, that's a function value. But when we're thinking of limits, let's see if I make all this work. We're going to keep that. This is where I'm going to bring in a graphing calculator. Get rid of that. Let's see, Numworks. So actually I've downloaded this. You can do the same thing with this. You download it, you get a simulator HTML. It's actually a browser-based calculator, and this is actually a calculator. So you can use this And then if you were to buy it as a calculator, it looks exactly like this, a little white plastic thing with things, and you can use it. But until you become comfortable with it, let's go here. We can just go ahead and use it here. Let's see. See if I can make it a little bit bigger. Let's go with that. We are going to use the grapher. And we're going to add an element. Go down here, x equals y, or y equals x. And we're going to put in 2 plus x. That's our function, right? And what we're going to do is we're going to go up. I have to hit OK. We're going to go up to the table. We're not going to go to the graph, or we could. We're going to go OK. And what we're looking at is what happens as x gets close to 3, right? Let's see. Make this bigger. So as x gets close to 3, so we see when x is 3, it's equal to 5, and that's what we call the limit. But what I want you to do is really see that the limit is as we get close. So we're going to go 2.9. And so if I put in 2.9, I got 4.9. Well, that's kind of close to 5, isn't it? And if I go 2.99, 4.9, I'm getting closer to 5 from that. So that's the concept of the limit. As I get closer and closer with as my x gets closer to 3, my y is getting closer to 5. That's the limit. And if I come from the other side, that would be like 3.1, just a little bit bigger than 3. And I say I have 5.1, so that's pretty close. And again, I play with this. Let's go with 3.00001, and that's pretty darn close to 5, right? So if I come from the left or the right, my limit, as my x is getting closer and closer to 3, my y value, that limit's getting closer to 5. That's the concept that we're dealing with. And what we're going to need this for is when we have functions that are undefined at the value that we're at. In a business situation, it may just be that's a missing piece of data. So you don't have the data for December 25th, 2022 or something. That was missing, Christmas Day. How could you miss that data? So you've got to use data from other sides, right? What, as I got close to that date, what was happening as I after the date. Maybe you go do a historical look, but that might be the example that you look at. It might not be you have a function, but you may be able to use this concept of limit in data analysis techniques. Okay, does that kind of make sense that all the limit is really the output of the function so far? Okay, good. So we're going to look at a couple examples, and we'll get to one specifically that we'll come back to that calculator, and we'll see that it's undefined at the place we're looking, but so far that's what we do with limits. And so you're going to see most of the homework, it's these kind of things. Just plug it in, and you'll get your limit. But then if you can, maybe on one or two of them, do this little thing with the graphing calculator, just kind of sneak up, and so you say, okay, the limit is as I get closer to the x value, the y is getting closer to this output value. Okay. Now here's one. We're going to need a numerical approach with this. So let's just try this same thing that we just did, right? Okay, we said we want x to go to 2, so let me just plug in 2. So this is 2 to the third minus 8 over 2 minus 2. What's 2 to the third?
8.
It's 8. And 8 minus 8 is, and 2 minus 2 is, and 0 divided by 0 is, okay. It's called the indeterminate form because it should be either 1, because something divided by itself is 1, right? Or maybe it should be 0 because anything is 0. But the thing is it's one of these things that if you say it's one or the other, half of the mathematics stops working. So we can't really say it's one or the other, and it's undefined, right? It's indeterminate. So we put in 2, we can't get an output. Right? It just does not exist. D and E does not exist. So this is where we use limits. Let's see if we can, what happens as we get close to 2. If we've got some values that we could use as we get close to 2, we could use this concept of limit. Even though we know when we're at 2, we don't know what's happening, right? So the way we do that is, again, we're going to keep this. We just come to our graphing calculator. Let's make it a little bit bigger. Let's see. Go here, over to expressions, and I'm going to change this to x to the 3rd power. What was it? -8, right? Divided by, was it x minus 2? X minus 2. And then I could look at the graph, but the graph won't be, I have to click OK. We're going to go up to our table. And again, I've messed around. It's kind of nice, it puts the equation in here. So I'm going to put in just 2. And exactly, like you said, it's undefined. The calculator even knows it's undefined. But what we're going to do is we're going to sneak up on coming from the left and the right. So what's a number that's close to 2? 1.99. And yeah, let's not mess around with 1.9. Let's get closer. Let's see if, so yeah, 1.999, you know, so you'll get to this. What are we close to? That number looks like it's close to 12 is it. So then what we do is we come from the other direction. And again, you could go, okay, let's add another 9 or a couple more 9s, and you'll see you'll get probably as close to 12 as you want. But let's come from the other direction. What's a number just a little bit bigger than 2? 0, put all those in there, and we put enter. 12.00. Yeah, it looks like if this was going to be anything, it's going to be about 12. That's our limit. That's all there is to it. We did a numerical look. Now, occasionally we'll get this thing is getting bigger, and this is maybe going to negative, so we'll see how that looks graphically. So for that, we're going to say they're not going towards the same number. But when they're both kind of getting, as you know, we put more 0s here and more 9s there, we can see we're going to get as close to 12 as we're going to get it. That's the limit. That's all there is to it. Okay. And again, we're not going to have you, it used to be we'd have you do the algebra of factoring this thing, and again, that's where we spend a lot of time. But y'all are business majors, you don't need to factor. To do it with the engineering folks, they might need to do the manipulations of the math. You need to make decisions about, do I raise prices or lower prices? Do we make more or do I hire, you know, you need to get decisions made, and that's what we just did, is we said, okay, if we call it 12, we're good. Okay, we go on the graph. Okay, so we can do this graphically too. So as x is getting close to 6, it's, let's back up a little. So here's 6. So we're coming from the left towards 6. X is going towards the left from from the right. And so what we do is, what that looks like is on the graph, what is the y value doing when we come this way? What is it doing when we come this way? Looks like they're both going towards -4. So we can say that this limit is -4 from the graph. Now we might not know, -4 might be a hole in the graph. Sometimes it doesn't show up, but it could be. But so we're not saying that this function has a value at 4. All we're saying is that the limit, as we get close enough, is going to be 4. Okay. And it could very well be there, but also it doesn't have to be with the limit. Is that good? So there's going to be a few homework problems. They give you a graph. You're just looking left and right. Are they going towards the same? Where we start to run into problems, something like this, right? We're going to 2. We're coming from the left, coming from the right. Now we notice this one is going this way, this is going this way. And so as they get closer and closer to, as x gets closer and closer to 2, what is the y value getting close to? -2. So we would say this limit is equal to -2. End of story. Here's one where we're going to maybe have this is where the limit sort of gets interesting. So far it's been real boring, right? Now it's just going towards that point, that's what it is. But this is where it's sort of interesting because it doesn't work, right? X is going towards 2, it's from the left to the right, so what's happening to the y? From the left, y is going towards what value? So the limit as x goes to 2 from the left, g of x, that's -2. What's the limit as it comes from the right? It's 0. So the limit as x goes to 2 from the right of this function is 0. Is 0 and -2 the same number? No, you can see it's not. There is no limit. So up here, there's individual left limits and right limits. You don't get into that in the homework, but that's just for free. This one, the limit does not exist because it's not going towards the same place. You got a bigger construction project than filling in a pothole. Got to build a bridge or something, I don't know. Or you got to move the other part. And that's limits. What we're going to, I think that's the last one. Yeah, closed form, this is what we were talking about. Again, I won't take, this is available to you to take a look at if you want. But basically, closed form are all the types of functions we deal with, even these funky ones. These are all what we call closed form. They're a single expression that gives the whole function. The things that are not closed form are when we're dealing with this sort of thing, which is called a piecewise function. We will deal with those a little bit later, but also they used to have this in this context as well. In the piecewise functions, it's at the edges of the pieces where oftentimes we need limits. But they've taken those problems out. So, and part of this was a conversation between the business department and the math department. The business said, if you're not getting our students through and you're teaching a lot of math they don't need. We're business majors. We want you to teach them the math that's going to be valuable for them as business majors. So we revised the curriculum. I did. Well, I'll take credit for it, but I wasn't involved. But I would have told them to do the same thing. Okay. So this is just saying that this, in most cases with closed forms, we're able to actually just plug it in and get an answer and we're fine. So like this last example, I know this one's the last one. We can just plug in 1, right? 1 to the third minus 8 over 1 minus 2. What do we get? We get 1 minus 8, 1 minus 2, which is -7 over -1, which is +7. That's our limit. Okay, and if we went back to the graph of this, we could see, because we still have it up here, we'll see when x is 1. Oh, I got rid of it. Let's see. Let's change this back to 1. When x is 1, y is 7. And that one we didn't have to do all the numerical magic with it because we can plug it in and we can get it. But at 2, we had to look at it numerically because 2 was something that doesn't, when we put in x equals 2, we don't get a value. But we would get close to 12 from the left and the right. Okay. So make sure you get into your WebAssign, get registered in that. You'll be able to see, you can go into 10.1. If you want to wait a little bit, that's fine. It's no hurry on it, but there's about 8 problems in there, similar to what we just worked through. And that'll lay the foundation for what we're going to do on Wednesday.